Hi, everyone. My name is Zoe Lai, and I conducted this research with my mentor, Ollie Fector. So today I'll be talking about TDP-43 inclusions and neuroplasticity in the entorhinal cortex during Alzheimer's disease. So this is kind of the 4 points that I will be going over today. First is the introduction. So Alzheimer's disease is defined as a neurodegenerative disease with no current identified cures that causes a decline in cognitive function, mainly in memory. It's a very complex disease because it contains polymorphisms, mutations, and non-genetic factors. It's marked by amyloid plaques, loss of neuron activity, and interneuronal fibrillary tangles. Uh, it's categorized into three stages: mild, which has minor cognitive complications and can affect your day-to-day life; moderate, which is generally the longest, and you can see significant behavioral changes, making it more difficult to do daily tasks. Severe is when the brain tissue deteriorates, and it can cause severe memory loss, loss of mobility, and inability to complete daily tasks. Episodic memory, one of the hallmarks of Alzheimer's disease is impaired episodic memory. It is a long-term declarative memory that deals with the recollection of one's own personal experiences, which is facilitated by the medial temporal lobe. It is the ability to comprehend, store, and retrieve recent memories from personal life, like recalling the specific time and place of the event. So, for example, people may forget events such as what restaurant they went to last night, like what they ate and who was there with them. The entorhinal cortex is a specific structure within the medial temporal lobe, and its specific function is to support memory. The EC is the main channel between the hippocampus and the neocortex. Specifically, it delivers information to the hippocampus, and then it translates that information to the neocortex using glutamate, a neurotransmitter. It is often impacted early in Alzheimer's, making it an important structure to study to better understand cognitive decline. Neuroplasticity, it is very crucial for functions like memory and refers to the brain's ability to restructure itself using neural connections. But in Alzheimer's disease, neuroplasticity is significantly impaired, which contributes to cognitive decline. As I mentioned earlier, Alzheimer's is marked by the presence of amyloid plaques and tau tangles, and it is thought that these proteins lead to synaptic dysfunction and interferes with the brain's ability to perform neuroplasticity. Although amyloid plaques and tau tangles are the primary proteins associated with Alzheimer's, the presence of TDP-43 and aging-related tau astrogliopathy, or I'm going to call it RTAG, have also been shown to disrupt neuroplasticity and cognition. TDP-43 is an intranuclear protein that is involved in the regulation of gene expression. When TDP-43 does not function properly, it can accumulate abnormally in the brain, such as in the entorhinal cortex, and it has been found to be associated with other neurodegenerative diseases. The accumulation of RTAG pathology can happen with the normal aging, but if there is excessive buildup of the tau protein, it can lead to neurodegeneration. And the picture on the right is of the TDP-43 found in the brain. There are currently limited tools available for measuring the disruption in neuroplasticity. So to overcome this, the current study focused on these two types of neuropathologic changes and analyzed whether the presence of TDP-43 versus RTAG pathology in the entorhinal cortex differentially impacted cognition in individuals with Alzheimer's. So my first aim was to examine the relationship between TDP-43 and episodic memory performance. The second aim is to examine the relationship between mild, moderate, and severe levels of RTAG pathology and episodic memory performance. Next, I will be talking about my methodology. So for participants, this analysis included 185,832 participants from the National Alzheimer's Coordinating Center, NAC. NAC is a centralized data resource hub for the National Institute of Aging's and Alzheimer's Disease and Research Centers program. This includes 37 centers in the United States. For my demographics, the study participants were predominantly male and mostly white. The ages ranged from 51 to 101, with an average age of around 80.5. The participants were all further classified based on the presence of TDP43 and RTAG pathology. So for TDP43, they were classified whether or not they had detectable amounts of the inclusions. For RTAG pathology, it was separated into mild, moderate, and severe tau found in the entorhinal cortex. The craft story from the UDS cognitive battery involves having participants learn and later recall a short story, and my current study focused on the delayed memory score to represent episodic memory. So to address AIM-1 and examine the relationship between TDP43 and episodic memory, we conducted an analysis of covariance or ANCOVA test to assess whether there are significant differences in memory scores between individuals with and without TDP43 and the entorhinal cortex while controlling for age, sex, and race. To address AIM-2 and examine the relationship between archaic pathology and episodic memory, we conducted a second ANCOVA test to assess whether there are significant differences in mild, moderate, or severe levels of archaic pathology in the entorhinal cortex while also controlling for age, sex, and race. And these are my results. For AIM-1, we found that participants with TDP43 inclusions in the entorhinal cortex performed significantly worse on the craft stories task than participants without the TDP43 inclusions. We also found that age, sex, and race do not have significant effects on the composite craft scores. For AIM-2, we found that there were no significant differences in craft story performances across mild, moderate, and severe levels of RTAG pathology. And these are my conclusions. In conclusion, having TDP43 inclusions negatively affects episodic memory, while RTAG pathology across mild, moderate, and severe levels does not significantly impact episodic memory in Alzheimer's disease. It's also important to note that these relationships were true regardless of sex, age, and race. While considering the impacts of these neuropathologic changes on neuroplasticity, it appears that TDP43 negatively affects neuroplasticity while our tag pathology may not. And some limitations to my study were that there isn't like a real measure for neuroplasticity, so our tag was used as a proxy measure for neuroplasticity, and also sex and race were unequally distributed. So further research could further examine the relationship between TDP43 inclusions in the entorhinal cortex and Alzheimer's disease, which can inform the targeting of future drug trials. And these are my references. Thank you, everyone.
Thank you, Zoe, so much. Kind of a similar question for you. Did you choose this topic as a personal reason, or is this just something you wanted to learn more about? Do you plan on studying it in college, or what drew you to the topic?
I've always been interested in neuroscience, and it's something that I want to pursue in college. And specifically, I was really interested in neurodegenerative diseases, and that's what kind of led me to this.
And do you still feel after doing this research that that will be something you want to pursue in college?
Yes.
Great. That's great. A couple questions that I had for you. One, I found it interesting, right, that of a study of 180,000 people, most were men, right? It was 60%, I think,
Yeah.
most men. But it seemed like in the analysis of the study, you didn't find too much of a correlation between the severity or the amount of TDP3 in men, women, men or women. It seemed pretty even though more men in the study. Is that true?
Yes.
Um, And when you talked about episodic memory, the example that you gave was you might not remember where you went out to eat last night or what you had for dinner, right?
Yes.
Do you find that does episodic memory, is that mostly closely related with short-term memory, or does that also include like wedding dates, birth dates of children, or is it mostly short-term?
Episodic is mostly short term, so like they can remember stuff from like long time ago, but just recently.
Got you. And do you know in the study, was there anything that said what contributes to high levels of TDP3?
Um,
Are there causes of it? Like, was there anything that was drawn in the research that said, hey, these things we feel may lead to more TDP3 buildup?
I don't remember there being like a specific cause of
Hmm.
like um when TDP-43 like aggregates abnormally, but just when it does, it can contribute to Alzheimer's.
Yeah, gotcha. That was great. Thank you. Thank you a lot. That was great.